Welcome to my YouTube channel once again. In this video, we're continuing with the problems of Lagrange multiplier. So we're going to look at an example, and the example is as follows. Find the extremes of the function. The objective function is given, subject to the constraint, and the constraint is also given. So without wasting time, we just go directly to the solution, and then we have the solution. Remember, we first of all form the composite function, and form the composite function. We have L equal to the objective function is what, xy, and then minus the usual lambda that will always multiply the constraint, and we know the constraint to be what, x squared plus y squared, and then minus 8, which is the constant. So now we differentiate with respect to what, x, the L, the x, which is going to give us y minus, we have 2x multiplied by lambda equal to 0, right? Remember the steps. If you don't know how we got this, you refer to the first video, the methods of Lagrange multiplier. The explanation is there. And then from here we try to make lambda the subject formula, that is from this equation, and then we can now say our y is equal to what, 2x lambda, right? And then for us to make lambda the subject formula, we have lambda is equals to y all over 2x, and then we can call this equation 1, right? The second step is to differentiate with respect to the L, the y. And when we do that, we are going to get x and then minus 2y lambda, right, equal to 0. And then we solve for lambda, we get x is equal to 2y lambda, and then our lambda will be equal to x all over 2y. Sorry, we call, yeah, this is equation 1, and then we now call this our equation 2, right? So we add more page. The next is what? Find the derivative with respect to lambda itself. And when we do that, we are going to come up with x squared plus y squared minus 8, right? We can call it minus 8 equal to 0. We can call this equation 3. Yeah. So the next step is what? Equate lambda is equal to lambda. The lambda in equation 1 is equal to lambda in equation 2. And that will be y all over 2x is equal to x all over 2y. Cross multiply, we have 2y squared equal to 2x squared, right? Divide both sides by 2. We're gonna get y squared is equal to y. Sorry, my apologies. Y squared is equal to x squared. Yeah, and then let's take the square root of both sides. We take the square root of both sides, we're going to come up with y is equal to x. So we can simply call this equation 4. Yeah, so we have y is equal to x. So remember, all we need to do now is to substitute the value of either x or y into either value of x equals to y or y is equals to x into equation 3, and that will enable us to find one of the variables. So in this case, we're going to substitute the value of y is equal to x. So substitute the value of y is equal to x into equation 3. So we have x squared plus x squared minus 8, equal to 0. And we have x squared plus x squared equal to 8. So we have what? 2x squared equal to 8, right? So let's divide both sides by 2. When we do that, we have x squared equal to 4. And then when we take the square root of both sides, square root of 4, this will be x, and then this will be 2. Our x is equal to 2. Remember, our y is equal to x. So to find the value, we need the plus or minus sign, and therefore we have plus or minus sign. Therefore, our x is equal to plus 2 or minus 2. Yeah, right? So let's add more page. Yeah, so to find the value of y, we substitute x equal to 2 or x equal to minus 2 into equation 4. So how we can do that is, we know that y is equal to x, and then we know that x is equal to 2 or minus 2. So our y will also be equal to 2 or minus 2, since y is the same thing as x. Therefore, since the question is asking us to find the extrema, we now solve it in this way in order to find the extrema. That's the minimum and the maximum. That's what we're looking for. So from the objective function we know, which is x and y, and remember what the question give, the various combination that we can have is, this is the objective function. The various combination we can have are f, we have 2 and 2, and then we f, we have 2 and minus 2, we have f, we have minus 2 and 2, and then we have f minus 2 minus 2. What that means, the first one is when x is equals to 2 and y is equals to 2. When x is equals to 2, y is equals to 2. The second one is when x is equals to 2 and y is equals to minus 2. The third one is when x is equals to minus 2 and y is equals to 2. And then the fourth one is when x equals to minus 2 and when y is equals to minus 2. So we can say for maximizing, we have when x is equals to 2 and when y is equals to 2. What would that be? We have 2 times 2, and that will give us 4, right? Or that's for me maximizing still. Also, we have when x is equals to minus 2, and then when y is equals to minus 2, where we have minus 2 times minus 2 will still give us 4. So when we are maximizing, we use the value of x equals to 2 and y equals to 2, or x equals to minus 2 and y equals to minus 2. And then for minimizing for minimizing, we have f is equal to 2 or minus 2, yeah, isn't it? That is 2 times minus 2 will give us minus 4. That's the minimum value. Or we have f minus 2 and 2. That is, we have minus 2 times 2 will give us minus 4. So these are the relative maxima, the extrema. That is, for minimizing, we either use x equals to 2 and y is equals to 2, and then we can use also x is equals to minus 2 and y is equals to minus 2. We get the maximum value. And then for minimizing, we can use x is equals to 2 and y is equals to minus 2. We get the minimum value of minus 4. Or we use x equals to minus 2 and y is equals to 2. We get the value of the minimum value of minus 4. Thank you very much. I hope this video helps. Please don't forget to subscribe, like, and comment, on the videos to encourage me the more. Thank you. Bye.